last class, we have discussed about polar plot in control system and how to sketch the polar plot and what is the procedure, what are the advantages and disadvantages. And at the end, we have taken one simple example of the polar plot. Okay, how to construct, how to sketch the polar plot for the first order system. Now we'll take another example here. So from the last class we are taking just it is addition of one pole, or you can take here so two terms here. Sketch the polar plot for the given transfer function 10 over s plus 2 into s plus 4. So that is the given transfer function. For this you need to sketch the polar plot. You need to draw the polar plot. So here first step is again same thing only. You need to convert into frequency domain, substitute s equal to j omega. So in the given transfer function, substitute s equal to j omega. We'll get here 10 by j omega plus 2 into j omega plus 4. This is the transfer function here in frequency domain. Now it has a magnitude and phase. So magnitude is 10 over square root of omega square plus 4, this is the first term, and second term omega square plus 16 square root of that. Okay, so similarly you can find the angle. So numerator it is having constant term 10 plus 0 I, so that is angle is 0 only. So denominator here we have two terms separately, that is the main advantage in frequency domain. Individual terms separately you can take angle and we can add if it is a multiplication of number of terms. So that is the main advantage of frequency response methods. So tan inverse omega by 2 for the first term and second term plus tan inverse omega by 4. So that is equal to minus tan inverse, because this one it is a division, it can be converted into subtraction only. Minus tan inverse omega by 2 minus tan inverse omega by 4. Another step, next step is just substitute the values of frequency 0 to infinity. You can take here, because these are the again simple values only, simple transfer functions. Here directly you can take the 0 value and at the end value, starting value and end value, omega equal to 0 and omega equal to infinity. Directly we can get the polar plot. So at t equal to omega equal to 0, magnitude is, so here we are not converted into standard, directly you can take because already it is there. So 10 by square root of 4 in this magnitude, we substitute the value of omega equal to 0, 10 by square root 4 and square root of 16. So that is equal to 1.2. And the angle is minus tan inverse 0 minus tan inverse 0. So total angle is 0. At omega equal to infinity, magnitude is so 10 over square root of infinity into square root of n. Total it is 10 by infinity 1. So that is 0. Angle of that is a tan inverse infinity, it is a 90 degrees minus 90, again minus 90. So total it is minus 180 degrees. Now from these two values, at omega equal to 0, magnitude is 1.25, while angle is 0 degrees. 0 degrees is that is the real axis, and this is the value. So at this frequency omega equal to 0, magnitude is 1.25, that is the real value, positive value. Okay, from origin you can take here 1.25. It is starting. At the end point it is omega equal to infinity. At that time magnitude is 0. But you need to observe that so angle, how much angle it is. So that is a minus 180. Minus 180 means you need to take clockwise direction. So that is from this 0 to, you need to take minus 180. Okay. So this line, it crosses somewhere here, minus 90 degrees. If you want to find that value, because in this problem you ask only sketch the polar plot did not ask whether it is crossing as in axis, where it is crossing. So just drawing the polar plot. Okay, so it starts at real axis at omega equal to 0 and ends at omega equal to infinity with an angle of minus 180 degrees. Okay, so that is the final polar plot for the given transfer function. Okay. Next, we'll take another simple example. These are the typical sketches for polar plot. Here I am not drawing everything, so just step by step how to find out, particularly by observing these things in competitive examinations. Directly you can observe so what type of system it is, transfer function. From that polar plot you can find, or from the given transfer function you can draw the even polar plot also. That's the reason I have taken simple and typical sketches for polar plot. So if you are taking type 0 system with the order 1, so this one g of s equal to 1 over 1 plus system. This is the first order transfer function. Here type 0 is nothing but pole at origin. In this transfer function there is no pole at origin. That's why, so order is 1 only, highest power of s is 1. That's the reason this transfer function is called type 0 order system. So substitute s equal to j omega in this, we will get 1 over 1 plus j omega t, and it has a magnitude and angle, that is a phase. So 1 over square root of 1 plus square omega square into t square, that is the magnitude, and this is the phase. Okay, already frequency is varying from 0 to infinity. You take two values, so directly we can draw the value. So no need to go for the imaginary axis crossing a real axis. Directly take omega equal to 0 and omega equal to infinity. At that time, magnitude, when you are substituting equal to 0, so 1 over 1, that is the magnitude is 1, angle is 0. When as omega tends to infinity, so magnitude is 0 only, 1 by infinity 0, and angle is minus 90. So starting point, frequency is 0, at that time magnitude is 1, that is a real axis positive value with an angle of 0 degrees, and end value is minus 90 degrees with magnitude is 0. This is the simple graph we can, so this way as omega increases from 0 to infinity. This is the first order transfer function. Okay, in the last class also we have taken one example. This is the simple way. We can, even for 1 or 2 marks also, we can directly find out both, either vice versa. From the transfer function we can draw the polar plot, or from the graph we can find the transfer function. Similarly, for the type 1 and order 2, just you see here, just compare with the first one. Here one pole it is adding, that pole is at origin. Okay, that's the reason pole at origin. So depending upon type changes. So here it is a type 0 and here it is type 1. But here order is 2, because when you are multiplying s plus s square t, so that is highest power is 2. That's called it is the order of the system. So again same system, only say same procedure. Substitute s equal to j omega in this, separate, that is a magnitude and angle, phase. Again take the omega equal to 0 and omega equal to infinity. Find the magnitude and phase for each case, and see here when omega equal to 0, so this value it is, magnitude is infinity, it is somewhere here infinity at omega equal to 0, and end, that is omega equal to infinity, angle is minus 180 degrees and the magnitude is 0. So this is a minus 180 degrees line. So this line with the magnitude 0 only. So starting it is minus 90 degrees and it is passing through, as frequency is increasing, it will pass through this line and end at omega equal to. So this is type 1 order 2. transfer function. Similar way, we can find number of transfer functions. We can draw easily polar plot for the given transfer function. Okay. So in the next class again we'll take some more typical sketches for the polar plot and also how to find the stability of the given transfer function by using polar plot. Okay. Thank you.